Okay, good morning or good afternoon, year 12. Some of you have told me you're stuck on exercise 2C and 2D. So the questions I'm going to go through today from exercise 2C are questions 7, 8 and 11. And from exercise 2D, I'm going to go through question 7. If you've got any other questions, I'm very happy to make an extra PowerPoint. Just send them in to me. Okay, so let's look at this question here from exercise 2C. Okay, so this is a composite function, stuff that you did at GCSE, but probably not as complicated as this. So the key is we do S on T of X. So we're going to do S on T of X. So instead of writing T of X, we write what T of X is. Now, we know that the function S maps whatever is in S, it maps to what you're putting in. So what are we putting into S? We're putting in X plus 3. So therefore, S of X plus 3, so X plus 3 is in our box, is 2 to the power of X plus 3. And that is your answer. Now, you could change that if you wanted to. Okay, it could say it's 2 to the X times 2 to the 3. Remember, when we times bases where we've got the same base, we add the powers. So this is exactly the same. And we could change that to, well, we know 2 to the 3 is 8. So this is the same as 8 times 2 to the power of X. So that's your answer for part A. Okay, part B, which I know some of you got stuck on, working out T S to the X. So we want to do T on whatever S to the X is, and S to the X is this function. Now what does T do? T maps whatever's going in to T, whatever's in the box, it says it's the box, add 3. So in this case, our box is 2 to the X, add 3. And that is your answer. Okay, so those are our 3 answers to begin with. Right, this is the hard one, which I know part C, quite a lot of you told me this was a problem, so well done for telling me that. You must tell me if you're stuck and you don't understand the solutions, and I will go through them. Okay, so you want to solve when both these mappings, these composite functions, are equal to each other. So we're looking at S T to the X is the same as T S to the X. Okay, I could put brackets around there. Right, well I've worked out S to the X, which was 8 times 2 to the X. I did that in part A. Part B, I got this. Okay, so this is what I'm now solving. So I'm going to take all my x's to this side. So I've got 8 lots of 2 to the x minus 1 lot of 2 to the x equals 3. So let's just put a 1 here. Right, so I've got like functions here, like terms. So 8 lots minus 1 lot will give me 7 lots of 2 to the x equals 3. It's that step going from here to here that I think may have caused some confusion. Okay, so I've got 8 lots of something minus 1 lot of something is 7 lots of the something. And in this case, the something is 2 to the x. Okay, now we want to get this into ln form. So 2 to the x is 3 over 7. Right, what should I do to both sides to find x? Well, whenever x is a power, to release the x, to release the power, we ln both sides. Okay, so we get this. We've got to ln both sides. And then the rule of logarithms means I can bring the x forward, the power rule of logarithms, and I get this. By the way, this does not, okay, this ln 3 over 7, some of you may think this is ln 3 over ln 7. That is not correct, okay? That is not true. Right, so please be careful, that's not true. Right, so what will my x equal? My x will equal ln 3 over 7 divided by ln of 2. And that is your answer. Okay, so well done. Right, let's look at the next question. The next question some of you struggled with was question 8. This question here. So find your workings out on this. So the first bit, another composite function, find g on f of x. So what I'm doing here, doing g on f of x. So I'm replacing the f of x. Remember, I work inside out. Okay, so I know that my g of whatever I'm putting into my g function is 4 lots of ln of whatever I'm putting in. Yeah, so here the x is my box. Okay, so what am I putting in? I'm putting in e to the 5 of x. That's what's in my box, is 4 lots of ln, writing down what's in my box. Okay, so we've got that. Now you know that linning and eing are inverse functions, like squaring and square rooting, like adding and subtracting. So they will cancel each other out. So this is the same as just 4 times 5x. Ln and e are inverse functions. So you get back to the beginning, i.e. the beginning, e on 5 of x, then ln it is just 5 of x. So I get 20x as my answer. That was hard, this bit, this step here. Okay, really crucial though, understanding linning and eing are inverse functions. Okay, let's look at the next step. F on g of x. Okay, f on g of x. So this is what g of x is. F on g of x. Right, what does my f function do? My f function is this. So I'm going to write that as a box. So my box is the x. Yeah, x is inside my box. X is inside my box. In this case, what is in my box? I've got 4 ln x. Okay, so just think of this not as an x now, but as a box. Let's just colour that in. Okay, so I've got e to the 5, what's in my box, what's going into f, times 4 ln of x. Now, we want to simplify this answer. So this is the same as saying e to the 20 ln of x. Now, e and ln are inverse functions, but I can't do the inverse yet because I need to change this to e ln of x to the power of 20. Remember the power rule? Okay. Now E and Lynn, okay, I can now cancel the E and the Lynn, okay? Because at this stage here, E and the Lynn are not just pure, Lynn is not just a pure function, it's 20 times Lynn x. Now the E and the Lynn are next door to each other, they are inverse functions, so they will cancel. So this is the same as x to the 20. So it's this step here, going from here to here, that some of you may struggled with. Some of you may put the answer down as 20 ln x, but you have to have the e and the ln next door to each other, just the ln of the function itself. Okay, next question is question 11. Really good question. I've seen this one come up lots of times in the exam. So really important, this question here. Very, very important. Right. First of all, you've got the sketch of g of x. You're told these points. You're told the domain. The domain is all your values of x. It starts at -5 and goes to 14. And it includes -5 and 14. Hence, you've got solid dots here. If it didn't include -5 and 14, these would be open circles. Okay, the range. So the range is all my values of g of x from the bottom to the top. Well, g of x takes in all the values from -8, it starts at -8 and goes all the way up to 12. Okay, so g of x, the smallest value it will ever be is -8. The largest value it will ever be is 12. And because you've got all of the values, there's nothing that's not included between -8 and 12. It's all the values of y. So therefore, there's nothing excluded here. Right. And next, this is the tricky bit. Finding g of 0. g of 0. So the first thing I want to find is g of 0. So g of 0. Now this is my function g. So I'm putting x equals 0 into g. Yeah? So when x is 0, if I go up, I get g of 0 to be 12. So g of 0 is 12. Now I'm doing g on 12. G on g of 0. G of 0 is 12. Okay, so what's g of 12? So this is my function g. So I go along x until I get to 12, which is about here. And I would need to find what is my value of y when x is 12. That's what this is asking for. What is the value of y when x is 12? Well, I can't see that from the graph straight away. What I've got to do is look at this straight line and decide what is the equation of that straight line, which I can easily do because I've got the 2 points on the straight line. So this is the tricky bit here. So let's look at how we find g of 12. So I'm just going to go back to this graph here, guys. So I've got my straight line here. Let me just write it out again. So it's starting 0, 12 and it's going to 14, 5. If I can find the equation of this straight line, then I can work out what the value of y is when x is 12. Okay, so I know the equation of any straight line is y equals mx plus c. So if I look at finding the gradient of this line, I can see it's a negative gradient. So I'll have a negative m. Okay, so I want the change, so the gradient is the change in y over the change in x. Yeah, that's my rule to find the gradient. So the change in y, what's this, the up? The change in y goes between 5 and 12, or 12 minus 5. So 12 take away 5, which is going to be 7. Yeah, is the change in y. The change in x is going to be 0 take away 14. So this distance here is 14, from 0 to 14, the change in x. So I've got 7 on the top, I've got negative 14 on the bottom, so my gradient is -1/2. Okay, so I've got -1/2 x plus c. Well, what's my y-intercept? I can see straight away my y-intercept for this line is 12. So c is 12. So I've got my equation of this straight line here. Now I want to know what's the value of y when x is 12. Okay, so what's the value of y when x is 12? That's what I'm trying to find. So I'm going to put 12 into my straight line. So if I put that in, I'll get -6 plus 12, so I'll get my answer of 6. Okay, so so I got g of 0 is 12, and g of 12 from the equation of the straight line, my value will be 6, and that is my end answer. You may need to follow that through again, a difficult bit, this bit here. Okay, part C, the last part to this question. You're now given a new function h of x, and you're asked to find g on h of x. G on h of x. So let's first of all find out what h on 7 is. To find out what h of 7 is, I'm going to put 7 in place of x. So 2 times 7 minus 5 over 10 minus 7. So I'm replacing the x with the 7. 14 minus 5 over 3. 9 over 3, which is 3. So h of 7 is 3. Now what I'm doing is I am working out g on h of 7. Yeah? Well, I know my h of 7 is 3. Just work that out. So I'm working out what's g of 3. Right, let's go back to the graph of g. Here's my graph of g. And I want to work out g of 3, i.e. I'm putting 3 into my graph, and I want to see where it hits this line. Now, I've already worked out the equation of this line from the previous question. And the equation of the line was this: y equals -1/2 x plus 12. Or I could say g of x equals -1/2 x plus 12, because y is the same as g of x. So if I'm putting 3 now into here to find g of 3, I've got -1/2 times 3 plus 12, which will equal -1.5 at 12, which will equal 10.5 is my answer. So that's question 11. Okay, right, next question. This was exercise 2D, question 7. 2D, question 7. I think actually what I'm going to do is do this in a separate video.